Hello, everybody. We are going to be looking at this week just a review of Chapter 9. Chapter 9, remember we were looking at all of the properties of quadratics in detail, seeing how they worked, what they look like, being able to solve every single quadratic that we come across now, and also being able to graph quads and being able to put those into that graphing form. So I'm just going to do a really quick review. If there's anything that you struggle with, remember, go back in Plan Book and look at the previous videos. I've shown you in detail how to do these things, with the exception of the first half of Chapter 9, because remember that was before we left. So what we're going to start off with is reviewing those ways to solve quadratics. That was the first thing that we looked at. Now, the very first way that we had to solve them was we solved by factoring, and this didn't actually happen in Chapter 9. This actually happened in Chapter 6, a long, long time ago. So if I have a quadratic equation that looks like this, what I can do is I can factor this to solve. And remember, hopefully at this point your factoring skills have gotten to the point where you can factor these pretty darn quickly. Once I've factored it, now I can use that zero product property. So I've got x plus 2 equals 0, x plus 3 equals 0. So x is negative 2, x is negative 3. If a quadratic factors, we want to solve it by factoring because this is so quick and easy. There's hardly anything here. The next way that we looked at, this was the first one in Chapter 9, was we looked at using that square root property. Using that square root property to solve meant that we were going to get something squared by itself and then take the square root of both sides. So I might have something pretty simple that looks like this, right? So I can add 9 to both sides, so x squared equals 9. I can take the square root of both sides, so then x is equal to plus or minus 3. Remember, if I take the square root of both sides, that plus or minus has to pop in there. So my answer is positive 3 or negative 3. We also looked at some that were much more complicated than this, like maybe an x minus 3 squared plus 5 equals negative 3. And for this one, I still have something squared. I want to get this thing by itself, so I'd have an x minus 3 squared. I'm going to subtract 5 from both sides, equals a negative 8. I can still take the square root of both sides. That plus or minus is still going to pop up. So I've got x minus 3, thank you, is going to be equal to plus or minus. This simplifies a whole lot. I've got a negative inside there, so I'm going to have an I that pops out. This is 4 times 2, right? So I've got a negative 4 times 2. So I can take this part out, so I'm going to have a 2i root 2. So x is equal to, adding 3 to both sides, I've got 3 plus or minus 2i root 2. Still using that square root property, but sometimes it's a little bit more complicated, and sometimes our answers are not as nice and pretty as the ones that we just looked at. Right, the next thing that we looked at was, what if I want to use the square root property, but it's not in this form? So what if I've got y equals x squared minus, or not y equals, I'm sorry. I was looking at my wrong example. Let me start over. I've got x squared minus 8x plus 10 equals 0. So my first goal is to get this over on the other side, because I want to get this thing by itself. And I'm going to be adding something to both sides. I want to add something so that I will end up with a perfect square trinomial on this side so that I can factor it into something that looks like this. So what I do is I take my b divided by 2 squared. Remember, b divided by 2 and then square it. That's what I'm going to add to both sides. So this is going to be a negative 4 squared, which gives me a 16 to add to both sides. This side factors into an x minus 4 quantity squared. This side gives me a positive 6. Now I can take the square root of both sides, nice and easy, remembering my plus or minus. I've got x minus 4 is equal to plus or minus root 6, and I can then add 4 to both sides. So I've got 4 plus or minus root 6. So this is completing the square. I didn't write that down. Okay, the next thing that we looked at, and the very last one that we looked in terms of solving these things, is looking at using the quadratic formula. Right, and the quadratic formula, we all know, is very helpful. It can solve any quadratic equation that you need. Any one at all, it will solve it. It's not always the best method, but it's a way to solve any quadratic formula or any quadratic equation. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And remember that if I have a quadratic equation, it's in this form, ax squared plus bx plus c equals 0. That's that standard form, right? So I'm actually going to solve the one that I solved previously using completing the square. I've got x squared minus 8x plus 10 equals 0. So for this one, I know that my a is 1. Remember, it's that invisible number in front of my variable. If there's nothing there, it's just a 1. My b is not just 8, but a negative 8, always remembering to look for those signs. And then my c is going to be a 10. So now I just need to plug all of these pieces into my quadratic formula. So I've got negative 8, plus or minus the square root of negative 8 squared minus 4 times 1 times 10, all over 2 times 1. So x is, I've got 8 plus or minus. In here, this is going to be a 64 minus, this is 40, all over 2. So I've got 8 plus or minus the square root of 24 all over 2. Now this doesn't look the same as what I had before, but that's because it's not simplified completely. 24 is 4 times 6, right? So I can take out that perfect square. So I'm going to have plus or minus 2 root 6 all over 2. I can take a 2 out of everything here, which gives me that 4 plus or minus root 6, because I can divide everything by 2. Now, solving this one using the quadratic formula, notice we get the same answer that we did previously, right? However, when you look at these side by side, let me zoom out a little bit. One of them took a little bit more understanding of what we were doing, right? A little bit more of the conceptual work, being able to put this into that perfect square trinomial form. But once we did that, it was so much quicker to solve. There wasn't nearly as much kind of just tedious work. This one, you don't have to think as much, that's for sure, when you use the quadratic formula, but you do have to do a lot more of the tedious work. It's really easy to lose negative signs. It's easy to multiply things in here incorrectly. It opens the door for lots of little mistakes. I use the quadratic formula only when I really have to. That's my go-to. Otherwise, I try to use it, like I said, just sparingly. I don't use it unless I really have to. The next thing that we looked at was what if we have not just quadratic equations, but what if we have something that is in what's called quadratic form. So I'm going to put this one up here. I've got x to the 4th minus 14x squared plus 24 equals 0. So with something that looks like this, it's almost a quadratic equation. It's not quite, but that's because I've got a 4, right? Whenever my exponents are, when I've got these 3 terms, right? And my exponents are, like whatever this is 1/2 of whatever that is, right? This is 4, so this is 2. And then this is no exponent, right? There's nothing there. Whenever that happens, we have something that's in quadratic form. We looked at these before when we were factoring, and we used substitution to figure them out. And we can still do that if we want. We can substitute. We can say y is equal to x squared, right? And so here, this is x squared squared minus 14x squared plus 24 equals 0. Well, I can just substitute this in, right? So I can have y squared minus 14y plus 24 equals 0. This factors into a y minus 2 and a y minus 12. And now I can put this back in. So I've got an x squared minus 2 and then an x squared minus 12. I can still use my zero product property. X squared minus 2 equals 0. X squared minus 12 equals 0. So x squared equals 2, so x is equal to plus or minus root 2. On this side, x squared equals 12. So x, not x squared anymore. Take the square root of both sides. I've got plus or minus the square root of 12. Remember that that is the square root of 4 times 3. So that's going to be 2 root 3. So I end up with those 4 answers, which makes sense because I've got x to the 4th. Okay? So that's quadratic form. Where's my list? Ooh, and then the next thing we did, remember these videos are already out there for the next ones because we just learned them since we left, right? We're going to graph. Yay! Graphing quadratics. When we are graphing quadratics, we want to make sure that we are looking for and labeling all important pieces. Right? So when we're looking at those important pieces, we're looking for the vertex, the line of symmetry. Symmetry. Probably spelled that wrong. We're looking for the x-intercepts and the y-intercepts, right? That's that list of all of the important things that we're looking for. So I'm going to find those, and then I'm going to move to a piece of graph paper and graph one for you. So I've got y is equal to x squared minus 8x, or sorry, plus 8x plus 12. It could also be given to you in that f of x form, right? F of x is equal to x squared plus 8x plus 12. That works too. So for this one, we want to remember, find our line of symmetry first. And our line of symmetry is x, oops, see, it's not an x, it's got a weird little thingy across it. So x is equal to negative b over 2a. So remember, b is 8. It's that number in front of that. Remember, I've got ax squared plus bx plus c. So b is going to be an 8. So I've got negative 8 all over 2 times 1 for this one. So I've got negative 8 divided by 2. So my line of symmetry is going to be x equals negative 4. That's going to be my line of symmetry. Now to get my vertex, right, and actually I think I am going to graph it as I go. I think that might actually make it easier for us to really see how these come together. So I'm going to start, get my line here for my my y-axis, and then here is my x-axis. So my line of symmetry is at x equals negative 4, so 1, 2, 3, 4. That's right here. So I have a vertical line right here. And remember, it's not actually part of our graph. Anything that's not really part of our graph, we include it as a dotted line. It's like, hey, this is an important feature, but it's not actually part of my graph. So I know that my parabola is going to sit somewhere on this so that it can fold over, right? That means that the vertex is going to lie somewhere on this line. In order to find my vertex, I just have to plug in a negative 4. So if I use my function notation, I've got f of negative 4 is negative 4 squared plus 8 times negative 4 plus 12. So I've got 16 minus 32 plus 12. Oh goodness. So that's going to be 16 minus 20, right? I don't have a calculator. Yes, 16 minus 20 gives me a negative 4. So that means that the coordinates of my vertex are negative 4, comma, negative 4. That's going to be the coordinates of my vertex. So I can go back to my graph. 1, 2, 3, 4. Here is my vertex, negative 4, negative 4. Oh, can you see that? Yeah, okay, good. Sorry, I was on the wrong thing on my screen, so I couldn't see what I was doing. So once I've got my vertex, the next important things, so I've got my vertex, I've got my line of symmetry, I need my x and y intercepts. So in order to get my x and y intercepts, I've got y equals x squared plus 8x plus 12. If I want my y-intercept, that implies that x is equal to, that's right, 0. Right, so I'm going to plug in a 0 for my x. Y equals 0 squared plus 8 times 0 plus 12. I love finding my y-intercept because it's always really easy. I can just basically ignore my x's because they go to 0. Now, adding that to my graph, so here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I have to talk loudly, okay? Because otherwise it won't record. Okay, so I'll be done with this video in a few minutes, okay? So once I've got my y-intercept, I need to get my x-intercept. Sorry, my daughter's here with me helping make videos, so, but apparently I'm talking too loud. So if I want my x-intercept, just like when I wanted my y, x is 0. If I want my x, y is, yeah, it's 0. So these are the ones that are a little bit harder to solve for because I now have a quadratic equation to solve. But it's a good thing that we've got all of those wonderful techniques to solve these. So if you're looking at this and you don't see that it factors, then you could, or does it factor? Yes, it does. Okay. You could use the quadratic formula. You could complete the, I would probably complete the square if this one didn't factor, but this one does factor. It factors into an x plus 6 and an x plus 2. So that means x plus 6 equals 0, x plus 2 equals 0. So x is negative 6, x is negative 2. Right, so I can add those to my graph. So I've got x is negative 2, and then this is 4, there's negative 6. Right, so now I've got all of my important features. This is 0, 12. This is negative 6, 0. This is negative 2, 0. And I can connect my pieces. Oops. You know, I should probably make it prettier than mine, but that's okay. All right, so that's how we just graph a parabola. The next thing that we're going to be looking at, or the very last thing, was we looked at graphing form. Right, remember graphing form of a parabola is that f of x, or y, right, is equal to h minus k, or sorry, h minus f, start over. A times x minus h squared plus k. Remember that h, that's my horizontal shift, and it's always backwards from what we expected. K is our vertical shift. So that's the one that moves it up and down. And then A is going to be any squish, squish, or stretch. Right? If it's squished or if it's stretched out and made extra skinny. Or it also flips it up and down, right? Remember, if A is negative, then my parabola goes upside down. So if I'm looking at this one, the idea of those transformations, remember, is that we start with a parabola that has a vertex of 0, 0, right? That's where our parabola starts. It has a vertex of 0, 0, and my line of symmetry is right there. This is the most basic one. This is y equals x squared. The idea of that graphing form is it can tell me to move it back 4 and then down 4. It can tell me how to get it where I want it to go. Graphing form can be really helpful if all that you were really concerned with is just where it is. So if I have something like what I was looking at before, like y equals x squared plus 8x plus 12, in order to get it into this form, I have to focus on these pieces right here, and I have to complete the square with it. Right? Remember, I had, let me move this out of the way. There we go. This is x squared plus 8x. I'm going to add something to inside here. right? Whatever I add here, because I'm adding it on the same side, if I add it, in order to undo it, I also have to subtract it. Like in this case, I'm going to add 16, but I also have to subtract 16, because I can't actually change my equation. Remember, I got that 16 by taking b over 2 and then squaring it. So 8 divided by 2 is 4, squared gives me 16. So now I've got x plus 4 squared minus 4. So if I look at this, I know that my vertex is going to be the x-coordinates the opposite of this one, and it's going to be exactly equal to that one. Now, is that the same thing that I had for the vertex of the one that I just graphed? It sure is. So if I wanted to find that vertex quickly, that's a whole other way that we could do it. Okay? So that's pretty much it for reviewing of Chapter 9. So for this week, what you've got is you've got the Chapter 9 review. This one is every other even, because it is long, so it's every other even. Don't do all of them. You've got the Chapter 9 pretest, and then you've got the Chapter 9 test, not Chapter 9, Chapter 9. And I'm going to put test in quotes here because of our situation. It is open note, right? I can't really figure out a way to proctor it for all of you guys. I could try to do like a Zoom proctor, but that's not going to be very beneficial because you can still, I might as well just treat it like it's an open note test. In order to submit this, right, I would like you to please scan it if you can. So I know, possible. I know if you have an iPhone or if you have any kind of Apple thing, you go to the Notes app. And if you take a picture, then it asks you to scan it. Picture will scan it. If you have certain, oh, I don't even have my phone. If you have like my Android, some of them, if you just use the camera, if I just take a picture of something that looks like a document, it gives me a scan option instead. You can also get an app that will scan. That's going to be the easiest way for me to actually grade these. There will also be in Classroom a place for you to enter your answers. There's going to be a quiz. That way I can look at those answers quickly. That doesn't even say quiz. Okay. But I'm going to put some more information and maybe even a quick little video right before that quiz so that I can really be very clear on what I'm expecting for that. Okay, but that's all I have for this week. I might actually, in fact, I will. I'm just going to push the test into next week. So this is actually not going to be this week. This is going to be next week. Okay, sound good? All right, if you have any questions, remember, reach out to me. I miss you all, and I hope you have a wonderful day.